Hello everyone, my name is B9 and this is completely first video on this channel, completely first tutorial. And before we begin, I would like to really quickly talk about why I am recording this and why I created this channel. And the main reason is that Blender is being developed really fast and there is a lot of discussion, but the main sentiment is that hey, Blender is a hobbyist tool, nobody uses in production and stuff like that, or it's not ready, it's missing this or that. But in reality, I use Blender in the visual effects studio as a supplementary software to Houdini. I'm a Houdini artist, and whenever I try to do Houdini stuff in Blender or do stuff that Blender is doing very well, I'm always pleased with the result. Like, it never let me down. It's an amazing tool. And while there is a lot of tutorials about Blender, most of them they're about like, I don't know how to say this. I don't want to say professional, but they're lacking. Like most of the Blender tutorials on the YouTube are on the hobbyist level. Even though they show Blender stuff really well, it's lacking this kind of studio perspective or in-depth understanding of how geometry works, what are vectors and stuff like that. And I would like to change that. And the topic of today's tutorial is very simple. I found this Entagma tutorial, and Entagma is really good. Like, I really like them. I met Moritz once in my life. He's an amazing person, and they have amazing Houdini tutorials, and everybody loves them in the Houdini world. So they have this cable generator tutorial, which is in turn based on some article on SideFX website uh, that shows setup from Vladimir Lopatin, girly games artist, and it's quite old. So I don't know if he really works there anymore. Doesn't matter. And in this setup, they create this kind of cable generator that generates these tubes in a given volume, and they are kind of not intersecting each other. So the shapes are quite interesting that are produced from this setup. And I looked at this and realized that I can do this in Blender. And when I tried to do this, it took me some time to figure things out because there's kind of like quite a nodes that are missing. But in the end, after a couple of tries, I created setup that was really fast, really easy, and it uses this kind of Houdini logic of operating with attributes and iterating over geometry and stuff like that. And when I did that, it showed me how much powerful is Blender. And again, real real world scenario, Blender didn't let me down. It showed that it's capable, it's fast, and it has like, I don't know, I would say 80% of the things you need from the procedural uh, generation software, like node-based stuff. By the way, I'm talking about geometry nodes. And I really wanted to share this with people, so more and more people start like looking at Blender, that it's really capable, really powerful, and really great software. So let's dive in. I have an empty Blender scene, and I have enabled screencast case, so you see what I'm pressing on the keyboard and the mouse. So first thing, we will hit A and X to delete everything, and then we will create grid, some empty plane, and then we'll create new geometry nodes modifier, and let's call it cable generator. Let's do it with the capitals. So let's talk about our algorithm. So how we're gonna achieve the cables. Completely first thing, we will create a curve, just a straight line. Then we will turn this line into a cylinder. Then we will fill this cylinder with some points. Then we're gonna connect some of these points, like triangulate it into some kind of mesh, which will represent an array of all possible paths that our cables can take. And then we will use find shortest path node to generate cables onto this geometry. But in order to avoid intersections as much as possible. It's not 100% possible without some simulation and complex calculations, but with each cable, we're going to delete the points that were used. So with every iteration, there will be less possible ways. So this way we will achieve basically some basic avoidance of intersections. So let's start. I'm gonna cut the connection and make some room. Let's create curve line. Curve line. The start, we will do it along y-axis. So we will start with -2 all the way to 2 with 0 on the z-axis. So this will create a curve. It's over there, but unfortunately we can't see it. But maybe you can move it. Yeah, you can see it. And then we will do curve to mesh. And we need to provide a profile curve, which will be just a circle. Curve circle. Let's do 16 divisions. Let's plug it here. And we have a tube. And we can do fill caps also to create watertight geometry. Let's use radius of 0.2. And this is our starting geometry. Actually, let's do 0.5, so it's a bit thicker. Also, we would need these end caps as a separate geometry, but unfortunately this node doesn't give you any groups to delete, so we're gonna have to do it ourselves, and it's quite easy. We do curve to points. Let's plug our curve. Let's use count 2, so we get the starting and the end node, and then we will do instance on points, use our points and use our circle as instance, and let's plug rotation so it's aligned onto the curve. And when we plug it, we see this, but obviously we need it to be filled, so let's use fill curve node, and we have what we need. So let's continue with our points first. We will do mesh to volume. Let's see our volume. You see it has some kind of gradient. I think we can up the density a bit, so you have more even distribution. And then we will do distribute points to point in volume. Let's plug it here, and we have points. I'm gonna use some kind of higher density, but we will increase it later. Now we also need to scatter points here. So here on this stream we have 2 instances. We can use scatter on surface, not this one, scatter on distribute points on faces, sorry. And let's use higher density. Maybe 200. And the interesting thing is that when you distribute points on instances, you still have instances as an output. But it's good for us because we have only 2 instances, and we can say that instance number 0 is our start and instance number 1 is our end. And we need to write this information into the geometry, into the instances. So we do store named attribute. It can be integer attribute or float, doesn't matter. We will call it ends, and as a value we will use index. Index, and when we realize instances on the points, oh sorry, we should use on instances. So on the points now, you can see here, we can tell which points belong to the start and which points belong to the end of our cables. And next thing we can do is do separate geometry, split geometry, sorry. Oh, no, it's actually separate. Yeah, that's the thing. And we can use our named attribute as a division. And so let's plug this attribute. And now we have starting points and ending points. But we also need to join these two streams together to generate our triangulated geometry. I'll join geometry. I'm gonna take points from volume and also these realized instances. And here we have all the points. Now we can play a little bit with the density. But it should be good enough. So let's continue. We have our array point. Now the next part of the setup would be to iterating over each point, then filtering points by distance and also by the number, and creating connections. I can make little annotation to explain how it's gonna work. So we have some points. We're gonna loop through each one of them, and then we will define the radius, delete all the rest points, and then we will also select a defined number of them. So we can control the radius of the connection and also the number of points we are connecting, because if you have a lot of points, it can become really messy. So it's good to have this control. I'm going to delete the annotation. And how we're going to do this? Blender has for each loop, which been added a couple of versions ago, and this is exactly the use case of it. So let's create for each element, and it gives you these two nodes and the backdrop. And the idea is that you plug some geometry, you select what are you iterating over, and whatever happens in between these nodes is happening only for the current object. If it's point, then it's a point. If it's a face, then it's a face. So let's cut these connections, and we're gonna need a lot more room. So geometry goes into geometry, and inside we have, let's bring our viewer here. We should supposed to have only one point. Let's enable, yes, this is our current point. And if we select this one, hit N and go to the node settings, you can choose which iteration you are inspecting. This is quite handy. And what we also need is the position of this point. And in order to do that, we need position field to be plugged into the for each node's input. And we also need in value, we need the radius, and also we need number of points. So let's have this prepared. We plug this one here and this one here, and inside we have all of it. So we'll say maximum radius would be 0.1, and we want only 10 points. So first thing first, we need to filter by distance. So we grab distance node, plug our current position, and we need another position field, but this one will be outside of the loop, so it will be providing us all the positions of all the points in the geometry stream. And how do we define stream? We define it by delete geometry. So we need to plug this geometry here. I'm gonna create a reroute and plug it here. And we plug our selection. So if we did everything right, here we're supposed to have I don't know why it is not working, but it's supposed to be working. Ah, sorry, I forgot something. We need to test it against something, and that would be greater than. And we use our radius as a measurement. So here we should have points that are only closer than this radius. Yes, we have it. Currently we have 6 points. Okay, and the next step is we need to select them by the number, and the problem with this is that here is our point, here is the radius, and here is some point distribution. They have some kind of sorting, so if we just select first 10, we probably will end up with some kind of dispersion, but we want even distribution. And in order to do that, we can sort them by the random value. So let's do sort geometry, and we use random value as a driver of the sort. We plug it as a sort weight, and we need to have some kind of ID and seed, and we can use index. And then we can take index and test it against the maximum number of the points, because this index is basically this, the number of the point. So we say greater than, plug this here, and let's grab our maximum number. And this way we can delete, delete geometry. Let's take this one. Let's plug the selection, and right now it's set up at 10, but we only have 5, so we can take 2, and we get 3 points because we are counting from 0. But this one, basically we need to subtract 1 from the, add 1 to the index before we can do this, but I think it's fine, have an extra point, it doesn't matter. So let's have some room. And at this stage we have all the points that are tested against distance and also the number that we can use for the connection. And in order to connect points together, we need another loop, nested loop, for each element. And we will loop over each one of these points and create the mesh line between its point's position and our current point position from the initial loop. Let's bring this position over here into this loop. Let's grab another position because we need current point's position, and we can create mesh line. Set it to endpoints, count to 2. We don't need extra points, so it will run faster. So we grab this as a start point, this as endpoint, and let's plug mesh as output, and let's plug this one as output of our loop. And if we did everything correctly, we should be able to plug our output here, and we have our connection. I'm gonna erase all the annotation. And what we can do now, we can play with the maximum number of connections, and we can also play with the radius. So the bigger the radius, the more points then can connect. And this is our basically connect adjacent pieces algorithm. We can select all of it like this, hit Ctrl G, tab out, and we have our own custom node. I'm not sure about this. It should be like this. There was a mistake. And we don't need this last extra geometry. So, and actually we can also put this position inside. Position, because we don't need it outside. And this way we can unplug it and also delete it. Yes. Now, if we unplug these two guys, we have a parameter on the node. And we can call it connect. I'm gonna publish this node probably on Patreon that I will create with this channel, or on the Gumroad, or both. Go to the link into the description. I don't know yet how it's gonna be published, so let's follow up on this. So I plugged these guys back, so I like to have these controllers. And we have our geometry, and we're gonna start using shortest node path, shortest path node, sorry. So here's the idea. We will pick one point over on this side, one point on other side, and then use this entire network to build a way through this geometry to the endpoint. So let's delete and let's dive in. And we're gonna do this in the loop. So let's create a loop. Repeat zone it's called. And what it does, it takes some geometry in, you modify this geometry and you plug it out, and then this gets plugged in internally back here. And it's like endless loop. You can control how many iterations you want to have. And this way you can run some kind of node setup multiple times. So let's plug it here. And we have our shortest edge path. And we also need second one, edge path to curves. These nodes work together. This is interesting setup. You plug this guy here. And what you need is defined mesh. And on that mesh, you need to tell it the start points and the end point. And for each cable, obviously, we need one point as a start, one point as an end. We can already start plugging it here. How do we define start and end points? Well, before we prepared this part. Oh, sorry, I deleted the setup. Let's do it again. Split, separate geometry. Separate geometry, yes. And we have this ends attribute. Named attribute. It's integer as far as I remember. Yes, and it's called ends. We plug here and we should have start and end points. By the way, I'm just clicking. So we need to select random point here, random point here. How do we do that? Well, we can use random value. We can go already here because we will need some attributes from our repeat zone to do that. Because for each iteration, we need to select different random point. We switch it to integer. So each point has an ID. So if we select random number between 0 and maximum number of points, this will give us exactly 1 point. And to do that, we need domain index, domain size, sorry. Switch it to point cloud because this type of geometry is point cloud. Plug our geometry and we should have point count, so we can use it as a max. And we also need ID and seed to be driven every iteration different, so let's plug it here and here. So this gives us ID of the random point, and we need the position of that point because we will use sample nearest to find equivalent point on our main geometry, because as you remember we joined them, so each point from the start and end also exists in the main geometry. And this node needs position, so we need to sample that one. So sample index, sample index. This is our index. We want to sample position, and position obviously is a vector attribute, so let's switch now to the vector. And we need our input geometry. So do some housekeeping. And we can sample that position on our main geometry. But we need to do this for the second set of points, for these ones. So let's copy all of this. Let's flag our geometry. Let's flag our iteration number. And we also need to plug the geometry. And we need second sample index. But this just gives us index of that point. And for this one, this diamond input, it means that we need to give it a list with a true and false. So basically Boolean lists for every point to select it. And we can do that with a compare node. Compare, switch it to integer, and we can compare index of that point with our selected index. And we should switch it to equal. Let's do this again with the second set, and this can be our start vertices, and this could be our end vertices. So theoretically, if we plug it as output, and by the way, we need to plug it as a separate output, because if we plug it here, it will override the input geometry for the next iteration. We can also grab these guys together. Let's see what we have. And we have nothing. And the reason for that, one of the reasons is that this geometry, basically we sampled each point twice. I will make some annotations. Sorry, I always forget. So if we have 2 points, when we were iterating over this one, we grabbed this point, so we created one line. But when we were iterating over this one, we created another line towards this way. And for some reason, this algorithm doesn't like overlapping edges, but to fix this, we can do merge by distance. Merge by distance. And we have our first cable. And if we plugged everything correctly, sorry, I need to switch back to the grab. Each iteration should give us different cable. Yes. So we're always getting one cable out of this, because every iteration we are overriding this output. But what we need to do is merge it with the previous iteration. And we can do this by join geometry. So if we join this curve with the previous one from the input and plug this guy as output, we should have more cables every time. Yes, but as you can see, some of the cables are using the same path as before, because this one is the shortest. So we need to start deleting points. Let's do that. For that, we need to define the radius of the curve. So basically everything within the radius of the curve, we need these points to be deleted. So the next cable will be not using this as a source point. And to create a radius, we will use random value. We will drive this value by the iteration also. I'm gonna cut the connection so the scene is a bit faster. And we're gonna go between 0.01 to 0.1. This will be the radius. So let's set curve radius. It will be here. We will use this radius for the meshing of these cables later. And also we will use this to delete points. So let's do delete geometry. Let's plug it here. And we need to measure against our radius. So we do less than, and we also need the distances. So we can plug this for now here. For that we will use geometry proximity. And we need to plug our curve, but geometry proximity only accepts meshes. So we need to convert our curve to mesh. Curve to mesh. Like this. And now we can measure the distances and let's see what we have. Oh, and we forgot to plug our radius from the random value. And what are we deleting? Oh, we need to do it on the points. Yes. So with each iteration, we would have less and less points here. Yes. See? And let's see what we have in terms of cables. We have our cables, and they are kind of not intersecting, but they are disjaggered because we used straight lines. What we can do is convert it into a NURBS line, so it will have smooth corners. Set spline type. Let's plug our curve. Let's switch it to NURBS, and let's plug it here, and they are much smoother. So the next step would be to mesh them into tubes. So since we have curves here, we could use curve to mesh. We need a profile curve, which is circle, curve circle. And since our curves already have radiuses, we can use radius in the scale. And we have our curves. You can see a little bit of intersection here and there. It's because of this conversion to the NURBS, and because like it is not actually doing any collision or something like this. So you need to play with the values, maybe increase the deletion. For example, we could increase the radius a bit to deletion with the multiply, say by 2. Yeah, it doesn't really help, but let's save the scene and let's try to create more points, more dense setup. Yes. And then we can play with the iterations. Let's do 20. And how many max points we have? 5. Let's do 10. Yes. And also you might want to smooth them a bit to make them a little bit straighter. What we can do in this case is resampling. Sample curve. Yes, and the more points you have here, the smoother the lines, the less points you have, the smoother line will be. So if we do 20, it's a bit smoother, but the smoother it is, the more stuff is deleted. So we can do a little bit less deletion, which would give us more cables. And here is the setup. You have these intricate shapes. You can also play with the radiuses. For example, make this smaller, the thinnest one. Yeah, unfortunately, it is not entirely possible with this setup to avoid this small stuff of intersection. What we could do is to reduce maybe to 10 iterations. and increase the number of points to 1000. Let's hope it doesn't crash. It worked. So the more resolution in the input geometry you have, the more intricate shapes you will get, because there is more possibilities. And also what is also important is this start and end point density, because it gives us more starting and end possibilities. Yeah, here you have quite interesting shape. I have on my another screen setup I did for this tutorial and played with some settings, and here is what I get after playing with some settings. I think it's quite good. And then you can do some deformation with it, some curve deform or stuff like that. We could try it. Curve, now let's do Bezier. Bezier curve, and we can apply curve modifier. Pick our curve, and we need to go along different axes, I guess. Yes. So now you can start bending it. It's not gonna be fast because there is a lot of computation, a lot of geometry happening, but still you can play with it. You can bake the modifier, so it's a bit faster. What you can also do, let's go to our scene. Like for example, there is this bake node. Bake. It's a bit slow because every time you do something, it has to recalculate the whole thing. But if you plug it like this, bake, then it will use bake geometry on the disk. So it will be much faster. And what I would advise is to play with the settings. For example, at this part, bake it here, then this part will be faster. Then maybe bake the last step. So thank you. I hope you liked this tutorial, and I'm really looking forward to the next one. This one, the first, and I'm pretty sure it's not ideal, but I will try to improve. If you like what I do, subscribe and hit like. So see you on the next one. Ciao.